This is Algebra 2, Chapter 2, Section 4, about more linear equations, or more about linear equations. Uh, so, up to this point, we talked about slope-intercept form. And we said that slope-intercept form from the previous section is y equals mx plus b. We have another form. There's going to be two forms that we're going to discuss in this one. And the first of the two forms that we're going to discuss is point slope. The reason why they call this slope intercept is because I have a slope and I have the y-intercept. Point slope is in the form of y minus y1 equals m times the difference of x minus x1. And the reason why they have that point slope is because we have a slope. We have the ordered pair for one slope, x1 and y1. And the way that we get this one is from the slope equation. And this is the proof. Slope is equal to y2 minus y1 over x2 minus x1. I don't want this x2 minus x1 in the denominator. So what I'm going to do is I'm going to multiply both sides by x2 minus x1 over 1. What I do on one side, I do to the other. So this side is also x2 minus x1. That cancels. That cancels. I'm going to flip this around. That leaves me m times x2 minus x1 is equal to y2 minus y1. In point slope form, we take the 2's away. And I'm going to flip it there on the other side. And it's going to be y minus y1, which is equal to m times x minus x1, which looks just like the other one. That's how you get point slope form. So when they ask you here in the example, write an equation through line 7, 1 with a slope of -3. So our point is 7, -1. Our slope is -3. So I'm just going to substitute that in for the various parts. This would be x1. This would be y1. So then when I substitute that in, I have y minus -1 equal -3 times x minus 7. Then that would be y plus 1 equals -3 times x minus 7. This would be our equation. In point slope form. And then that's if they give you a point and a slope. You can also get point slope form if they give you 2 points. So an example of that would be the book gives us a point of -5 and 0 and 0 and 7. So we have -5 and 0 and 0 and 7. Our first step is to find the slope. So that's rise over run. So I would say 7 minus 0 over 0 minus -5. So I have a slope of 7/5. 7/5. So that's our slope. Nice. Alright, so now that we have our slope, we can just put it in point slope form. It doesn't matter which one I use, so I can actually have two forms, two different looking point slope forms, and have the same exact equation. So if I choose this one, the first point, I can say y minus 0 is equal to 7/5 x minus -5, which gives me y minus 0. It's nice to keep the minus 0 equals 7/5 x plus 5. That's one version. Another version. So that's one equation right there. You can use the other point. And I can use this one instead, and I can say y minus 7 is equal to 7/5 x minus 0. And I can leave it at that. And that would be my second version. Both of these guys are the same line. And I know they're the same line because they have the same slope. They just have different points. So if they have different points, it really doesn't matter which point you use, as long as you have the slope in the same place. Even though they look different, they actually represent the same line. All right, so standard form. The book gives a definition that I have always known it to be kind of incorrect. So let's talk about what standard form looks like. The conditions of standard form. Standard form is in a form of ax plus by equals c. Here's the first condition. A can be 0. And b can be 0. However, A and B can't be 0 at the same time. A can be 0, B can be 0, but they can't be 0 at the same time. Now, here's the thing where the book kind of makes a mistake. It says A, B, and C are real numbers. Notice they got crossed out and said it's integers. So here's why we say integers. A, B, and C can't be a fraction or decimal. Now, there's going to be an example in the book where it is, and I would ask you to disregard that. I've never seen it with a decimal before, or a fraction. A, B, and C can't be fractions or decimals, so they have to be basically whole numbers, hence integers. Lastly, A is, I'm going to put the word usually. A is usually positive. We usually want A to be positive. B and C, hence the word integers instead of whole numbers. B and C can be positive or negative. So can be positive or negative. So the conditions of standard form. A can be 0 and B can be 0. They just can't be 0 at the same time. A, B, and C can be a fraction or a decimal. A is usually positive. B and C can be either positive or negative. Okay. So those are our three forms that we've talked about in the past two sections: slope-intercept, point-slope, standard. Standard form is really good to find intercepts and for graphing in that regard. The best one for graphing is slope-intercept, but standard can really help you find both the x-intercept and the y-intercept. So for this one, I give you 2x minus 4y equal 8. That's standard form. We can see what happens when x is 0. So if x is 0, then we have 2 times 0 minus 4y equals 8, which is negative 4y equals 8. So then y equals negative 2. So 1 point is 0, negative 2. So that's your y-axis. And then what happens when y is 0? Well, if y is 0, then we have 2x minus 4 times 0 equals 8. Which gives me 2x equals 8, which gives me x equals 4. So we have 4, 0. So those are our two. So this is my y-intercept. This is my x-intercept. Remember that y-intercept is y when x is 0. X-intercept is x when y is 0. So when I graph this bad boy, 1, 2, 3, 4, 5. We have 0, negative 2, which is right here. And we have 4, 0, which is right here. And there we go. Okay. This one, they say that Office Manager has a small package. Office ordered Office ordered 140 packs of printer paper Based on average daily use, she knows that the paper will last 80 days. They want you to make a graph of this stuff. All right, so here's what the graph would kind of look like. The graph would look like this. It's just gonna be the first coordinate. Let's see, actually I might have to make this a little bigger. Okay. We have 140 packs. So we can go by tens. 10, 20, 30, 40, 60, 70, 80, 90, 10, 20, 40, 60, 80. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That is right. 10, 20, 30, 40, 50, 60, 70, 80, 90, 10, 120, 140. Okay. Now we have 10, 20, 30, 40, 60, 70, 80. Here's my 80 right here. 90, 10, 20, 40. Okay. This would be the number of days. This would be packs of paper. So time is usually your x-axis, or temperature. So that's the indicator for why I put days down here and packs up here. Our On the 0 day, we have 140 packs of paper. On the 80th day, all the packs of paper is gone, so we have 0 packs on the 80th day. So our line would look like that. Notice that it's a negative facing graph because we're losing stuff every day. So we have our two ordered pairs, right? Our first ordered pair is 0, 140. And the other ordered pair is 80, 0. Right, it's working just now. All right, our first step after we graph to put this, they want us to put the equation in standard form, is to get the slope. So slope is going to be rise over run. So 0 minus 140 over 80 minus 0. That gives me negative 140 over 80. The zeros cancel. Divide by 2, that's negative 7 over 4. So that's our slope. That's step 1. Step 2, we can put it in point slope form first in order for us to put it in standard form. So I'm going to use, it doesn't matter which one. Let's use this one, the 80 and the 0. So we'll have y minus y1 is equal to slope times x minus x1. And what we're going to do is we're going to substitute y minus 0 is equal to negative 7/4 x minus 80. So, yeah. One of the conditions is that we can't have we have to have our A and B be whole numbers, not fractions. So I'm going to multiply the whole equation by 4. I'm going to multiply the whole equation by 4. So y minus 0 equals negative 7 over 4 times x minus 8. I'm multiplying that whole thing by 4 across the board. 2, 3. What happens is that 4 is going to cancel down there, and that's going to give me 4y. I'm not worry about the 0 equal negative 7 times x minus 8. Then I'm going to distribute that 7 across, and that's going to give me 4y equal negative 7x plus 560. Then I'm going to add the 7x to both sides, and I get 7x plus 4y equals 560. This is my equation. This is my equation in standard form. So that's part B. The next thing they ask us is how many packs do we have after 30 days? So remember, x is days. So for part 3, we'll just substitute 30 for x. So it'll be 7 times 30 plus 4y equals 560. So that's going to be, let me use a different color because they're all blurring in. So 7 times 30 plus 4y equals 560. So I get 210 plus 4y equals 560. Subtract 210 from both sides, and I get 4y equals 350. And then divide by 4, and I get that after 30 days, it will be 87.5 packs of paper. Okay. All right. It's a pretty good problem. I like it. Okay, so parallel and perpendicular lines. If we have a line that is parallel, those are lines that never intersect. Right? They never intersect. And they don't intersect because their slopes are the same. Right? That's parallel lines. Then we have perpendicular lines. And perpendicular lines are lines that when they intersect form 90 degrees. So lines intersect to form 90-degree angles. Okay. Their slopes are negative reciprocals. Meaning, when I multiply these slopes, let's call it slope number 1 times slope number 2, it's going to equal negative 1. Negative reciprocals. Okay. So they want the equation of each line in slope-intercept form. So they want a line that's parallel to that goes through 4, 2 in slope-intercept form. So we just first have to get the slope. So what we can do is first we have it in standard form, right? So we have it in standard form. We just have to put it into slope-intercept form. So first thing we do is, doesn't really matter the line it goes through if we're doing it this way. Is we just need the slope. So the first thing we're going to do is I'm going to subtract 4x from both sides, which gives me 2y equals negative 4x plus 7. Next thing I'm going to do is I'm going to divide everything by 2, and I get that y equals negative 4 over 2x plus 7 halves, and then y equals negative 2x plus 7 halves. So this is the equation of the first line, but we want it to be parallel to the second line. So that's step 1. Step 2, now that we have our slope, that was step 1, this is step 2. Now that we have our slope, we can put it in slope-intercept form by substituting the points in. So slope-intercept form is into form of y equals mx plus b. All right, and our point is 4, negative 2. So we're going to substitute everything in. So we're trying to find our b. So we substitute negative 2 for y, negative 2 for the slope, 4 for the x, plus b, and we're trying to find what b is. That gives me negative 2 equals negative 8 plus b. Add 8 to both sides. B is equal to 6. So I have my y-intercept, I have my slope. So the last step is to plug it in. So I have y equals negative 2x plus 6, and that's my equation. That guy is parallel to the first equation, which was y equals negative 2x plus 7 halves. We have an equation, this is b, and it's y equals 2/3 x minus 1, and it goes through 0, 6. They want the line that's perpendicular. So what does the perpendicular line look like? So first step is to get the negative reciprocal of 2/3. So the original slope, call it m1, equals 2/3. So the negative reciprocal, m2, is equal to negative 3/2. So we found our slope. Nice. Second step, we can use point slope form, or you can use slope intercept form, doesn't matter which is which. The previous example I did slope intercept form. This example I'll use point slope, which is y minus y1 equals m times x minus x1. Our slope is negative 3/2. Our x and y is 0 and 6. So I can say y minus 6 is equal to negative 3/2 x minus 0. So then I get y minus 6 is equal to negative 3/2 x. Add 6 to both sides, and my equation is y equals negative 3/2 x plus 6. That is the equation of a line that's perpendicular to the initial equation. Okay, so that's that section. Hope you have a great rest of your day.